All right, so to continue the lesson, we're just going to go through a bunch of examples. So we're going to talk about how to identify vertex, axis of symmetry, the focus, directrix, the direction that our graph is going to open, domain, and range. So before we can do any of that stuff, it does have to be in vertex form. So if we're looking at these examples, all of these examples are either in the general form or just equations that we would need to put into the general form to start with, and then switch to vertex form. So to go from our general form to vertex form, we have to complete the square. So when I look at this, I know that this is in my general form because the squared term, so the x, are both on the same side, and then it's equal to the y. So whatever term is squared, those variables need to be together, and then the other one needs to be on the left side of the equal sign. And then we can start working on completing the square. So as we do this, we're going to leave space in between the linear term and the constant, and then we're going to add in another space at the end. So we'll have y equals x squared plus 8x plus, and then we're going to leave room to complete the square, plus 18, and then we're going to subtract that same number. So by adding and subtracting the same number on the same side of our equal sign, we're not changing the problem, we're just going to manipulate it to look the way that we want it to. So our next step, we are going to figure out what this number is. And again, we do that by taking the middle term, dividing it by 2, and then squaring it. So I'm going to write that factored form to start with. So 8 divided by 2 is 4, and then 4 squared is 16. So that's going to go into the blanks that we left. Okay. So again, the first 3 we are grouping and factoring, and then the last 2 terms we are combining together. So 18 minus 16 is going to be a positive 2. All right, so this is in vertex form. So from there, we should be able to find everything else. And we always start with the vertex. So the vertex is the opposite of what's on the inside, so negative 4, and then we keep the sign on the outside, so positive 2. And then the axis of symmetry, and the directrix, let's see, focus, directrix, and then the direction. And last is domain and range. Okay. Now looking at this, it's actually best to start to decide if it's going to be vertical or horizontal. And again, we do that by whichever term is squared. So since x is squared, we know that this is going to be a vertical graph. And then because we don't have a negative, a reflection didn't happen. So the direction is going to be opening up. Okay. So again, we're going to have a U shape opening up like this with the vertex at the bottom. So that means that our axis of symmetry is going to be a vertical line. So that's going to be x equals, and then the x value of the vertex, so negative 4. And then our focus is always a point inside of that U shape. So since it's on the inside, if we're thinking about what our vertex is, the h value from our vertex isn't going to change because they're right above each other. So we didn't move left or right. So the x value of our vertex is going to stay the same. So it'll be negative 4. And then this is a distance of c. So we're going to add whatever c is to the y value of the vertex. And from our equation, so from the first video, and then you should also have this note sheet. So if you don't have it, pause the video so you can copy down these formulas. So we're using this part right here. And then remember, our a value is 1 over 4c, and then c also equals 1 over 4a. So I'm going to take the a value of this problem. So that's just a number in front of the square term, so it's a 1. And we're just substituting it into that formula. So c equals 1 over 4 times 1, so that's just going to be 1/4. So we're going to add 1/4 to 2. And this one's easy to change to a decimal, so if we wanted to, we could just use that 0.25. Or if we want to write it as a improper fraction, we could also do that. So we would just take, so if we had 2 1/4, because we're adding, we would take 4 times 2, which is 8, and then add 1 to get 9/4. So the focus point is going to be at negative 4 and 9/4. And then for the directrix, so again, that's the line on the outside, and the directrix is a horizontal line, so it's going to be in the form of y equals. And then we take our h value, and we're going to subtract c from it. So again, that's going to be 2 minus 1/4. So that'll give us 1 3/4. So if we change that to be a mixed number, 4 times 1 is 4, plus 3 is 7. So this will be 7/4. And then the last thing is the domain and range. So again, because it's a U-shape opening up, our domain is going to be all real numbers, and the range is going to go from 2 to positive infinity. All right, so next problem, we're going to go through that exact same process. Okay. So this time, we have a number in front of our square term. So we know that a is going to be 2. And then since our x is squared, that's going to be vertical. And our a is positive, so we're going to have another U shape that opens up. So to remember, to complete the square, the number in front of the square term has to be a 1. So if it's anything else, we start by dividing everything by whatever number is in front of the square term. So I'm going to go through and I'm going to factor out a 2 from everything. So we're going to have y equals 2, and then x squared minus 6x plus 3. Okay. And then we're going to go through and complete the square. So again, I'm going to leave a little space here, and then at the end of it. So y equals, so 2 still, and then we'll have x squared minus 6x plus, we're going to leave a little bit of space, and then plus 3, and we're going to subtract the number that we are adding in. Okay, so again, we have that 2 in front. So again, we're going to factor first. So if we take negative 6 and divide it by 2, that will give us negative 3. And then negative 3 squared is 9. So that's the number that goes into both of our blanks. And we've already factored these first 3 terms. So now we have to combine the last 2. So 3 minus 9 is negative 6. And then because we factored out the 2 at the beginning, we have to remember to distribute it back in at the very end. So that will give us 2, and then in parentheses, x minus 3 squared. And then 2 times negative 6 will be negative 12. So that's the equation that we're going to be working with this time. So again, if we start with our vertex is going to be 3, negative 12. And then the axis of symmetry, so again, we have a vertical line for that. So it's going to be x equals 3. So, and I'm getting that from the x value of the vertex. For the focus and the directrix, we need to figure out our c value. So again, we're just using the equation c equals 1 over 4a. So we know a is 2, so that's going to give us 1 over 8. So again, the focus is inside, so we're going above the vertex, so we're going to add it to the k value, so the y value of our vertex. So that'll be 3, and then if we take negative 12 plus 1/8, that will give us negative 11 and 7/8. So again, if we change that to be an improper fraction, so we would take 11 times 8, and then add 7 to that, and it's still going to be negative. So negative 95 over 8. And if you just type this into your calculator, you can also change it to a fraction using that. So you'd go to the math key and then press enter, enter. And then for the directrix, that's our line on the outside. So it's horizontal, so it's going to be in the form of y equals. And then we are subtracting that from the k value. So we would take negative 12 and then minus our 1/8. So again, negative 12 and 1/8. So if we change that to be that improper fraction, so 12 times 8 is going to be 96, plus 1 is 97, and it's still going to be negative. So negative 97/8. Let's see, and the next thing, so our opening, so we already know that it's going to open up. And then the domain is going to be all real numbers. And the range is going to go from negative 12 to positive infinity.